Most AI projects do not fail because the model underperforms. They fail because the organization underestimates what it costs to make the model operational. The largest expense in automation is rarely intelligence. It is integration. When firms evaluate AI investments, attention gravitates toward visible numbers: training expense, inference cost per query, licensing fees, projected labor savings. These figures are concrete, modelable, and easily placed into a capital allocation spreadsheet. They create the appearance of clarity. But once an AI system moves from pilot to production, a second cost structure begins to form. It is distributed, incremental, and rarely captured in early projections. These are hidden integration costs, and they often determine whether automation delivers economic value on schedule or not. AI systems do not operate independently. They must connect to existing databases, workflow engines, approval hierarchies, reporting structures, cybersecurity layers, and legacy software. Most enterprise systems were designed for deterministic outputs, predictable inputs leading to predictable results. AI systems are probabilistic. They generate outputs with variability. Integrating probabilistic behavior into deterministic infrastructure requires translation layers, validation checks, exception handling logic, escalation pathways, and human review triggers. Those layers require engineering time, testing cycles, and ongoing maintenance. The model may function in isolation within weeks. Making it operationally compatible can take months. Integration cost does not announce itself. It accumulates quietly inside compatibility work. Data restructuring introduces another hidden cost. In controlled demonstrations, models are trained on clean, labeled datasets. In production environments, data is fragmented, inconsistent, and governed by complex access controls. Automation exposes weaknesses that human operators previously absorbed through judgment and improvisation. Once AI attempts to scale, these inconsistencies become structural obstacles. Firms must invest in data cleaning pipelines, schema standardization, expanded storage, and permission redesign. These investments are not enhancements to the model. They are prerequisites for integration. Automation does not eliminate data problems. It industrializes them. In many organizations, AI integration functions as a mirror. It reflects back years of accumulated legacy decisions, undocumented spreadsheet logic, inconsistent naming conventions, manual overrides embedded in workflow habits. When integration struggles, it is often not because the model is incapable, but because it encounters unresolved structural debt. AI does not create legacy debt. It forces firms to pay it. That payment appears as remediation projects, database restructuring, and process redesign, all of which expand the cost base before any efficiency gains materialize. Reliability engineering further expands the cost structure. A prototype can tolerate intermittent errors. A production system cannot. Reliability requires monitoring systems, logging frameworks, redundancy planning, failover mechanisms, and performance benchmarking. Capacity must be provisioned for peak demand rather than average usage. That excess capacity, compute headroom, storage reserves, backup infrastructure, represents capital deployed but not continuously utilized. It becomes part of the economic footprint of the system even when idle. In capital terms, reliability is insurance, and insurance is never free. Automation also generates redress cost. When AI systems produce errors at scale, organizations must build reconciliation capacity, teams that review disputes, override incorrect outputs, resolve edge cases, and manage customer friction. Savings in frontline processing often reappear as redress infrastructure. Automation does not eliminate service cost, it redistributes it toward exception management. In economic terms, efficiency at scale increases the absolute number of edge cases, and edge cases require humans. Workflow restructuring is another underestimated dimension. Automation rarely eliminates an entire function cleanly. Instead, it changes task boundaries. When AI handles part of a process, adjacent roles evolve. Employees review outputs, correct edge cases, manage escalations, and oversee exceptions. In many cases, firms discover they have not removed labor so much as redistributed it. 10 manual operators may become 6 reviewers and 2 escalation specialists. Labor expense declines, but not proportionally to early projections. Integration introduces supervisory layers rather than pure substitution. Automation rarely removes labor cleanly. It changes who absorbs uncertainty. Coordination costs also expand. AI systems alter decision velocity and information flow. Departments must negotiate ownership of outputs. IT absorbs infrastructure responsibility. Operations adjust service-level expectations. Finance reclassifies expenditures. Meetings increase. Project management layers expand. Change management becomes an ongoing operational requirement rather than a one-time transition. These coordination efforts consume executive attention and managerial time, both economically meaningful resources. Vendor dependency adds further complexity. Few firms construct end-to-end AI stacks internally. They rely on cloud providers, API services, middleware platforms, and specialized tooling. Each external dependency introduces contract negotiation, pricing tier management, usage monitoring, and performance oversight. Consumption-based billing models introduce cost variability tied directly to usage patterns. As adoption grows, spending scales dynamically. Budget predictability declines. Finance teams must implement new tracking mechanisms simply to maintain cost transparency. Variable pricing converts technological adoption into financial volatility. Security architecture reinforces integration cost. Connecting AI systems to internal data sources requires reconfiguration of authentication frameworks, network segmentation, and access controls. Logging expands to ensure traceability of data flows and outputs. Even without formal regulatory mandates, internal risk standards demand stronger controls. Each control layer adds engineering hours and system complexity. Testing at scale introduces additional expense. Performance observed in pilot programs does not always replicate in heterogeneous production environments. Edge cases multiply. Input distributions shift. User behavior diverges from expectations. Organizations frequently run parallel systems during transition, maintaining legacy workflows alongside AI-enabled processes. During this overlap period, infrastructure is duplicated and labor savings are deferred. Costs temporarily rise before any efficiency gains are realized. The economic pattern can be simplified. Model cost is concentrated and visible. Integration cost is distributed and compounding. The former is approved once. The latter accumulates across departments. When capital is committed based only on the first, financial expectations detach from operational reality. Training and organizational learning create recurring obligations. Employees must understand how to interpret AI outputs, when to override them, and how to manage exceptions. Documentation must be written and continuously updated as systems evolve. Staff turnover converts one-time training into ongoing expenditure. Knowledge management becomes a permanent operational function rather than a transitional effort. Measurement frameworks also require recalibration. When AI augments productivity, output volume may increase while error distributions shift. Traditional performance metrics may not capture qualitative differences between human-only and AI-assisted processes. Analytics teams must refine benchmarks to evaluate genuine performance changes. These refinements require time and analytical capacity, adding to operational overhead. Over time, integration can introduce architectural rigidity. Custom connectors, middleware logic, monitoring layers, and workflow-specific automation code create structural lock-in. The integration scaffolding built to make the system function often becomes deeply embedded in core operations. While model providers can be replaced or renegotiated, the surrounding architecture is not easily dismantled. In many cases, the ongoing maintenance of this integration layer represents a larger and more persistent cost burden than the model subscription itself. The intelligence can be swapped. The scaffolding cannot. Taken together, hidden integration costs accumulate across engineering adaptation, legacy remediation, data restructuring, reliability infrastructure, redress capacity, workflow redesign, vendor coordination, security reinforcement, parallel system operation, training, measurement recalibration, and architectural rigidity. None of these costs are speculative. They are consistent with long-observed enterprise technology transitions, from ERP deployments to large-scale cloud migrations. Hidden integration costs are not anomalies. They are structural. They represent the economic friction between theoretical automation and institutional reality. The model is acquired as a discrete expense. Integration is absorbed as a distributed burden. That distinction matters. Distributed costs distort financial clarity. They extend break-even timelines. They delay operating leverage. They suppress early margin expansion. And when expectations are set on model cost alone, integration friction becomes visible only after capital has already been committed. This is why many automation initiatives appear profitable in projection and disappointing in execution. The intelligence works. The economics take longer. Over time, integration stabilizes, systems mature, redundancies are removed, cost curves compress, infrastructure is optimized. But the transition period is capital-intensive and operationally heavy. In the cost layer of AI, the model is the visible investment. Integration is the compounding one. And for firms allocating capital under margin pressure, the difference determines whether automation strengthens the balance sheet or merely redistributes cost across it.